is our log laws. And for every exponent law you learned back in grade 9, there is a corresponding log law that works as well. So for example, do you remember this exponent law? It's equal to if you multiply powers with the same bases, then you can just add your exponents. Remember that from grade 9? So sometimes, right, sometimes if you step into a grade 9 class, teachers and students take out words. And they would just say, oh yeah, remember the rule? When you multiply, you add. Which is not true. When you multiply in math. When you multiply powers with the same base, you add the exponents. But often you'll just hear someone shorten it like, oh, when you multiply, you add. And then there's a kid like grade 5, you're like, I can't go to high school. They're messed up. So then the next day you're like, oh yeah, when you divide, you subtract. And they're like, what? But if you divide powers, right, with the same base, you can subtract the exponents. Well, in logarithms, they have a corresponding rule of if you are multiplying inside a logarithm, you can just decide to add the two logarithms together. And in the example that I just gave you, remember how I said that log base 8 of 4 plus log base 8 of 16 was equal to 2? Well, I'm adding two logarithms with the same base. I have the right-hand side of this log law. If you have the right-hand side of the log law, you could change it to the left-hand side, just like an identity. If you have one side, you can switch it to the other side. So the log law says that if you're adding logs with the same base, you can rewrite this as multiplying. And if I did 4 times 16, I would get 64. And now does it make sense that 8 to the exponent of 2 would be 64? It's a lot easier to see. And just like you have a power rule that says if you divide, you subtract. So in logarithms, if you're dividing inside of a logarithm, you can decide just to subtract two logarithms with the same base. And final exponent law, 2 to the 4 to the 9 would be 2 to the 36. If you have a power to a power, you multiply the exponents. If you have an exponent inside a logarithm, you can just say, I don't want that exponent in there. I'll just multiply in front. Now, all of these log laws can be proven, and your textbook even includes a proof for one of them at the bottom of page 389. We're not going to go over the proofs right now, but we need to get really good at working with our log laws. So that's what we're going to do. Question number 1 here. And I'm going to say, I have a log plus a log. Is there a log law that has a log plus a log? I looked on my formula sheet, and sure enough, it has log A of mn equals log A of m plus log A of m. Now, the left-hand side of all of those formulas is considered the simplified side. So whenever we want to simplify it, we would like to write it as one logarithm rather than multiple logarithms. And we would like to write it as one logarithm with no number in front. So here I have a log plus a log. This first log law says if you have a log plus a log and the bases are the same. So I notice the plus sign, and I also have to make a note that those bases have to be the same. This one has no base written, So these are common logs with a base of 10. So that means I'm allowed to take the right-hand side and rewrite this as log base 10, which I don't have to write, 7 times 8, which is log base 10 of 56. And now I have a single logarithm, and that means that it is simplified. It says use a calculator, so you could type in log 7 plus log 8, push enter. Here, we'll do it quick rather than just saying it. I could quickly check log 7 plus log 8 and check log 56 and notice that they are identical. In B, we have a number out in front, so I look on my formula sheet and sure enough, there is one log law that has this n out in front. And according to the log laws, it says that you can take that n and throw it inside the logarithm as an exponent. So I can take this equation, I can put that 5 in as an exponent, and 2 to the 5 is 32, so this would equal log of 32. And finally in C, they have a subtracting one. Again, I look on my formula sheet, and sure enough, if the bases are the same, and they are, and you're subtracting, and you have a log minus a log, we can write this one as log 80 over 16, which simplifies to just be log 5. Questions for practice are 4 and 12. I want to see if I have an idea. Smaller.